We've seen a function with multiple inputs, and now it's time for a function with multiple outputs. So we're going to walk through the whole process again. I'm going to open up a new script, new document that I will then turn into a function file by using the word function. But before we figure out what that's going to be, let's give ourselves a problem here. So multiple outputs, that's what we need. Let's think of a problem. Create a function file to calculate the, let's say, distance, velocity, and acceleration of a particular car for a given value of t, assuming all these parameters are initially 0. All parameters are initially 0. And by parameters here, I mean all distance, velocity, and acceleration are all starting at 0. So this car starts from rest. We'll give it some acceleration and figure out the acceleration is going to start at 0. Let's see what happens. So we're going to have multiple outputs, and the outputs are going to be a distance, a velocity, and an acceleration. Notice I'm using square brackets. Square brackets for outputs, round parentheses for inputs. That's how we do it. We could call these something a little longer if we want. Distance, velocity, acceleration maybe. The spaces are optional, but they can help with readability. Then we have our equal sign, and then we have the name of our function. I'm going to call the function just motion. And the only input is t. So we're going to have some variables created all using this input of t. 1 input, 3 outputs. We can have any number of inputs, any number of outputs. So as always, we will give a quick description of what we're doing. This function calculates distance, velocity, and acceleration of a car at time t. And then we would say inputs, we have t, time in seconds, and we have outputs, distance in, I don't know, meters, velocity in meters per second, acceleration in meters per second squared. All right, so not too concerned with what the equations are and what this does, but we need to produce a result for distance, for velocity, and for acceleration. So let's say acceleration is, let's just give it, so this is going to be something times t, let's say 0.5 times t. Velocity is going to be something to do with t squared. Let's say t squared over 4. And position, what did I call that? Oops, distance. Distance equals something with t to the third. T to the third divided by 12. And then we have the word end. So I'm not too concerned with what these equations are doing, just I wanted to be sure to give an output value for each one. So acceleration, velocity, and distance, make sure those match exactly what we said we were declaring. So I've got 1 input that I use, I've got 3 outputs that are all going to be produced. Now notice that I used dot exponent. Dot exponent, that allows us to have t be a vector instead of just a single scalar. So let's try it. Now that I've got this, I'm going to save it. And what does the name of the file have to be? It has to be the same name as the function name. That's a must. Over in our notes, I can put the call. Now that it's saved and it's in my working directory, I can use the function motion, and I could put in a 2 or something and run this section and get an answer. Well, motion, and I only got 1 answer. Oh, I know why. Remember when we did some of our statistical analysis functions, when we had multiple inputs, you have got to tell MATLAB you are willing to accept multiple outputs. I said inputs, I meant outputs. When you have multiple outputs, you've got to tell MATLAB, hey, give me those multiple outputs. Let me have them. And I didn't do that here. I just said, give me one. And so MATLAB gave me the first one. And that's it. And that's not what I want. So I need to say, oops, I need to assign the output to something bigger. So let's call it dv and a. I say, MATLAB, this function is going to give me 3 outputs. I want them all. They're going to be, I'll call them dv and a. Now when I run this section, I get 3. I get a D, I get a V, and I get an A. So all 3 are being saved. But this isn't very exciting if you just plug in a single scalar. So instead, let's say, let's call it something else, times. Let's give ourselves a whole list of times. Let's say from 0 to 30 in increments of 5. So from 0 to 30 seconds, and we're going to check in every 5 seconds. I don't need to see that, so suppress that output. And then here, when you call the function, I'm going to say, sure, D's, V's, and A's. We can call it something bigger if we want. But then the name of the function is motion, and I'm going to put in this whole vector, a whole array of values. Now when I run the script, I'll get this first, and then all of them get plugged in to the motion function. This is where MATLAB is very powerful with its vectors. You can send it all kinds of numbers all at once by passing a variable like this that has multiple values in it. And it will run through and do this much faster than if you tried to call this function a whole bunch of times and have it do it separately. So now when I run this section, I should have suppressed the output because now they're much bigger. But I get an A, a D, and a V with all kinds of values in it. So I could use this for graphing, I could do all kinds of things with it, and it's going to be easier to work with than if I had a whole bunch of individual scalar variables. Better to keep them in arrays if at all possible. Let's see if we can make these results a little bit prettier somehow. If I say results, and then I'm going to build a matrix like out of the times, and I'm going to transpose it. It is a row vector, but I'm going to put these in columns. So let's say the times, the distances, the velocities, and the accelerations, like that. And let's run it again. I'm going to suppress this one, and hopefully I get a better looking table in this by transposing all of my row columns into vectors. So run section again, and now we see that we have at time 0, all 3 are equal to 0, and we can see them changing. Acceleration over here, distance here, and velocity in the middle. All right, that's all for now. I'll see you in the next video.